So hello everyone, welcome to another particular lecture of our reagent chemistry series. So in the previous lecture, we have already discussed about the different selectivity associated in the organic reaction, such as regioselectivity, stereoselectivity, and chemoselectivity. So today, from this class onwards, we are actually looking to our different reducing reagents, such as nucleophilic reagent, electrophilic reagent. So in this particular class, actually, we are mainly focusing on the sodium borohydrides. Okay, we will see this type of things in our further discussion in the case of reducing reagents. So the nucleophilic reducing reagent is mostly associated with the sodium borohydride and their derivatives, lithium borohydride and their derivatives, zinc borohydride, lithium aluminium hydride, red aluminium hydride, and selectrides. Then we are focusing on the electrophilic reducing agent that provides the BH3 or B2H6, dival H, and ALH3, and solvated metal ion based reduction such as beach reduction, that is a sodium liquid ammonia based reduction. So this is our most content in the case of reducing agent, and after that we will talk about the hydrogenation part later. But in this particular class we are mainly focused on the sodium borohydride. Okay, so first we're talking about some information regarding the sodium borohydride reducing agent. So sodium borohydride is a moisture sensitive reagent, which is the physical property of the NaBH4 is it is a white to grayish crystalline powder, and this NaBH4 is soluble in water and certain organic solvents. And the sodium borohydride is used or known for being a mild and selective reducing agent, like we already discussed about the chemoselectivity. So chemoselectivity has takes important part in this NaBH4 based reduction. Okay, and NaBH the what actually NaBH4 job, the NaBH4 job is to commonly used to reduce the aldehyde and or ketones to their corresponding alcohols, and it is selective for the carbonyl group reduction and typically doesn't reduce ester, amides, or carboxylic acid under standard condition. So first let us understand about what the actually NaBH4 standard condition and what kind of solvent actually we are using in terms of NaBH4 based reduction. Okay, so give us in the next slide. So NaBH4, that the FAQs are there, like the facts of NaBH4. It is a mild and chemoselective reagent. It's actually mainly reduce the carbonyl compound. It is a hydride donor. So basically, if you see the structure of NaBH4, it is something like this. And this particular BH bond actually cleaves during the reaction, which forms a hydride H minus, and this particular H minus actually acts as a nucleophile which attacks to the carbon electrophilic center. Here there is a carbonyl carbon that is the electrophilic in nature. So this particular hydride will attack in the electrophilic center of the carbonyl compound, that is the carbonyl carbon, to generate the corresponding alcohol. So what kind of solvent actually used with the NaBH4? Like as I discussed in the previous slides, that NaBH4 will actually soluble in certain organic solvents. So usually it is observed that while we are actually dealing with NaBH4 in the case of reducing agent, so methanol or ethanol actually used as a solvent, and this particular solvent have a very unique role in the mechanistic pathway. So we'll discuss in the next slide. Okay, and the reaction condition is very mild. Like usually it will react in the 0 degree temperature, and also we get fruitful yield in the room temperature based reaction also. And NaBH4 doesn't react with protic solvent; it will only react with the aldehyde and ketones. And the final product is alcohol. So here you can see that this is the aldehyde and this is the ketone, which react with the NaBH4 to generate their corresponding alcohol. Now the corresponding alcohol might be primary alcohol or secondary alcohol, and it's depend upon the what the substrate has been reacted with NaBH4. Like if it is react with the aldehyde, then the final product will be the primary alcohol, and if it is react with the ketone, then it will form the secondary alcohol, and this is very obvious. So now let us deep down in the mechanistic pathway of the particular NaBH4 based reduction. So what the mechanism is that this is NaBH4, and as I already discussed that one of the BH bond getting cleaved, and so generate this particular hydride, Now this hydride will at a acts as a nucleophile, and this particular nucleophile will attack this particular carbonyl carbon, which is electropositive in nature. So what happened that this bond takes place, and the remaining O getting O minus, and this particular O minus are actually chelate with the rest BH3 present in the particular reaction medium. Okay, and thus getting stabilized. Now if we look closely here, then the BH3 contains more 3 hydrogen to generate the corresponding hydride. So what happened that this 3 hydrogen will also form hydride, and it will react with another 3 mole of our corresponding carbonyl compound, and to form this kind of gigantic intermediate. So here one point has been noted that if 1 mole of NaBH4 can able to reduce 4 mole of carbonyl compound. Uh, NaBH4 contains 4 hydrides, so 1 mole of NaBH4 is actually able to reduce 4 mole of carbonyl compound. Okay, and after generating this type of gigantic intermediate, so what happened that this particular BO bond getting cleaved in presence of solvent, so it is called the solvent quenching, and after solvent quenching we got our this product. Now as I already discussed in our previous slide, that the solvent have interesting role in the case of mechanistic pathway while treating a carbonyl compound with NaBH4. So here you can find here that one of the like in the initial part when the carbonyl compound is there and the product here, so the main difference is that 2 hydrogen is added in this particular uh, reactant, that is the carbonyl compound. So what happened that one of the hydrogen directly comes from the reagent, like here it is a NaBH4, and the other hydrogen is come from the solvent itself. So that we can say that the hydride or the hydrogen connected with the carbonyl carbon, which directly come from the reagent, that is a sodium borohydride, and the hydrogen that actually connected with the oxygen center that come from the solvent. And here we can the effect that I already discussed in the previous slide, that when NaBH4 react with the aldehyde, then primary alcohol form, and when the NaBH4 react with the ketone, then secondary alcohol form. Okay, so now let us talk about the general trend of NaBH4 based reaction. So NaBH4 usually attack from the less hindered side to avoid steric interaction. As an example, here it is a clean reaction of epoxide opening. So what happened that NaBH4 is actually generating this hydride, that is H minus, and this H minus will actually attack this particular center because it have the possibility of this two center. Now we can say the regioselectivity comes into the picture here, like this center getting lesser hindered over to this particular center. So this particular hydride actually attacks here, and the epoxide opening takes place to form this type of compound. And usually this type of trend has been observed that when actually NaBH4 used in terms of reduction reaction, then it will try to form attack from the less hindered side. But also there is an ambiguity is there, like under acidic condition hydride attacks observed from more hindered side. Actually this is happening when this particular acidic condition is there, that means the particular medium contains more hydrogen or H plus. So what happened that this particular lone pair from the oxygen is actually conjugate with this particular hydrogen or acidic condition. So this will generate a positive ion, and it will follow a loose SN1 mechanism. So what happened that now this particular bond actually mostly swept to this here. So the NaBH4, the hydride will attack here because now this particular center become electrophilic, and since it is a nucleophilic, so simply a electrophilic nucleophilic reaction takes place to form this type of major project, and this follows the loose SN1 pathway. So we'll discuss when we are actually learn about SN1 SN2 reaction, then we'll discuss in brief about the loose SN1 pathway. Okay, simply say that here after generating this type of intermediate, del positive or partial positive charge has been generated here which attracts the nucleophile more towards it. So irrespective of the corresponding steric hindrance, the nucleophile will attack here to form this as a major product. Okay, so there is also temperature selectivity of NaBH4. Like if your compound or if your starting material contains both the aldehyde and ketone. So in case of 0 degree temperature or room temperature, in the adequate amount of NaBH4, both groups are getting reduced. Like both the ketone and both the aldehyde group getting reduced to their corresponding alcohol. But if we do the same reaction in the low temperature, so what happened that only selectively aldehyde group reduced to corresponding alcohol and ketone group getting intact. This is because that aldehyde group is more reactive over ketone group. So usually when we actually reduce the temperature, we are actually increase the selectivity of the particular reaction, and this happen when in the case of minus 10 degree temperature, only the aldehyde part getting reduced, but in 0 degree temperature or in the higher temperature, the room temperature, both the group has been reduced. And in low temperature, more reactive aldehyde group selectively reduced. Now there are some exceptional NaBH4 reduction we'll discuss, that like if it is present in the diazo type of thing, like N2 is there, in presence of NaBH4 it directly form a benzene. So this is the exceptional NaBH4 based reaction. And also you have to know about the regioselectivity of NaBH4, like in the case of alpha beta unsaturated carbonyl compound. In presence of alpha beta unsaturated carbonyl compound, since NaBH4 has generated the hydride, and the hydride is actually a hard nucleophile, so it will obviously attack in the hard center. And in the case of alpha beta unsaturated carbonyl compound, the hard center is this particular carbonyl carbon center, and the soft center is this particular center, the beta carbon center. So in case of NaBH4, it's usually attack in the heart center, that is the carbonyl carbon. So 1,2 addition takes place. But the interesting thing is that in presence of these three, only these three compound, if this is your starting material, then NaBH4 shows 1,4 hydride addition. Only these three compounds. This is a very interesting exception. So you have to remember this. Like in the case of this compound, the 1,4 addition takes place. Like here is the hydride come. This particular hydride come from the boron center, and this will come from the solvent. And similarly, like if you have this type of compound, there's also NaBH4, and the hydride attacks here, and we get this particular compound. Similarly, if we have if this type of compound, alpha beta unsaturated compound on the 5-member ring, then it is also shows 1,4 product. But if it is have a 6-member ring, then it will form only 1,2 product. Like this particular bond is getting intact in case of 6-member ring, but in the case of 5-member ring, this particular 1,4 addition takes place. Now let us talk about the NaBH4 and tosyl hydrazone reaction. So if a tosyl hydrazone is there, so tosyl hydrazone in presence of NaBH4 generated this type of cyclohexane moiety. So let us understand the mechanism of the particular reaction. So what happened that this particular hydride actually attack in this particular center to generate this intermediate, and now this intermediate getting rearranged to remove this TS or tosyl part, because tosyl part a good leaving group to generate this type of part, and now this particular hydride will return back to actually eliminate the N2 from this particular mixture to generate this particular intermediate, and this intermediate in presence of a solvent quenching, it will generate this type of compound. So this is a very interesting reaction, and this particular mechanism actually confirmed by isotope labeling experiment. So isotope labeling experiment is something that we are actually using instead of using NaBH4, the people have using NaBD4, that is the isotope of hydrogen. So what happened that we get this particular product, similar product that observed here, and this product is only achievable when the particular reaction is followed by this particular mechanism. So the mechanism is confirmed by isotope leveling experiment. So with this, we have to end this particular lecture. So in this particular lecture, we have already discussed about the NaBH4, some kind of information regarding NaBH4, and also we are actually discussing about the mechanism and different kind of reactivity and some kind of exceptional cases, and the reaction with tosyl hydrogen. So in this next particular class, we are actually talking about the Luce reagent, that is the variant of NaBH4 based reduction. So thank you for listening.